I know you've looked a lot into the role that neuroscience can play in addressing some of these math education gaps. Is there anything in the neuroscience of learning that that might be instructive for us in terms of effective math teaching?
Well, so like I don't know about the neuroscience of it per se, but
Hmm.
like the activities that the researchers had found to be effective are the activities that are like if you're interacting with your student, many times you could be uh, reproducing them. You know what I mean? So like for parents, and I know this is for educators, when they go to the grocery store, they say, "Give me five bananas, go get me four more. How many bananas do I have?" That's one of the activities in our system for teaching addition. That's one of the activities that the researchers recommend that you're doing with the student. But at the end of the day, we're teaching them the language of addition, right? So there's
Yeah.
the, the difference really between mathematics and these other subjects, because we say, hey, well, math, it builds on top of itself. But yeah, but so does the rest of the world, right? So when I talk about a
That's fair.
government, right, like you can't just talk to a first grader about government. It's not a base idea. So like, but like at the same time, the problem is that mathematics has that calculation piece. And that calculation piece, I think, maybe triggers this math anxiety that we're talking about. And so now the logic around it starts to dissipate. But like, if the idea is first that the student understands the addition, like what is it, then that calculation piece comes along because the student sees the usefulness of being able to execute those calculations in a timely manner. And so like, um, I think that like I don't know like
No,
your
that was
sense of but
that was an
this is
excellent.
sort of like yeah.
No, that's an excellent answer, and I think it does point out what I think is a unique challenge that we have when teaching math. Is it's one thing for a student conceptually to understand that 3 plus 2 equals 5, but it's a separate pedagogical leap and often a very challenging one to be able to translate that into the real world setting that you brought up of if I'm at the grocery store and I have 3 bananas, how many more bananas do I have to buy to get to 5 bananas?
Right.
And the moment that it becomes real, that it becomes practical, now you're starting to bring language into it and words into it, and it's not just a two numbers and a plus sign on a piece of paper. That's an interesting pedagogical challenge, but it also is you know a learning opportunity, right? Because if you can find a way to make students understand that, if it gives relevance to the lesson planning, it can, sort of, I
Well,
think,
it's the
activate the
underlying
knowledge in them.
meaning behind the written mathematics. You see what I mean? So
Mm-hmm.
like the written mathematics, 3 plus 2, we're doing that in abstract, but in the real world, we do that with concrete things, right?
Yeah.
Like I bought 3 pens and then I bought two more and I have 5 pens now. But like if there's not an understanding of that concrete nature underneath the written mathematics, the question becomes, why am I doing this?
So
You see what I
if
mean?
the yeah,